Welcome to this YouTube channel. This is brought to you by Tech Global Network. If you find this lecture useful to you, please try to subscribe. Follow us on all social media platforms that it can be seen on our YouTube, on the top of our YouTube channel page. We're going to be uploading more content on electrical measurement. Now we're going to start this lecture note 1. We're going to be seeing what is electrical measurement. So electrical measurements are methods, device, and calculations used to measure electrical quantities. So these are the methods that we use in the measuring process of maybe an electrical quantity, or the devices we use. Example of such device is multimeter, other device that we use for measuring, and also the calculations we make when performing this electrical measurement. So all of them together is called electrical measurements. So measurement is the process of experimentally determining an unknown quantity using measuring instruments. So looking at it generally is for example, now you want to you have to measure something you don't know. So now it's like trying to physically determine the quantity or the value of a particular electrical experiment. You have to measure it. So that's what it's all about. So measurement is the process of comparing some unknown values with some assumed known values also. So measurement is when you compare some unknown values with the assumed values, like the SI units, like assumed value by international standard, comparing some unknown quantities with them to be able to determine the value of the electrical quantity. Measurement systems can examples are balance, balance to weight of an object. It's an example of a measurement system. And the process of adjusting a meter according to standard is called calibration. So the process at which you try to adjust a meter according to standard, a known standard, you have a standard that you follow and try to adjust the meter is called calibration. So now significant figures are very important in measurement. As you can see from the lecture notes, significant figures of a number written in positional notation are digits that carry meaningful contribution to its measurement resolution. So significant figures, as the word implies, significant figures. They are figures that are significant. They are figures that are relevant, in the measurement process. So now we're going to see some example, because we might be using them in the calculations that we're going to be going through. So now firstly, you see 843. We can see clearly that 843, all of them are significant. There are numbers that are digits that are significant. 843, so we call that's 3 significant figure. We have 3546. 3546. You can see clearly that that's 4 significant figure. Now, and mostly significant figures are non-zero values, like non-zero figures, like non-zero. So 10 is included. There are rules for that. So once zeros are included, then those zeros are non-significant in that particular figure. So like this one now is 0.75. We can see there that 75 is significant. It's a 2 significant figure. Now the process of measuring, we encounter errors. We can't say every measurement is perfect or it's accurate. So there are minimal error. And the focus of this particular course will be focusing on the errors that we can encounter when measuring when measuring possible errors, maybe due to the device that we use or due to some non-accuracy of the process, there will be small error. And so when we are writing this down experimentally, we need to we need to consider those errors too. Like for example, now when you see 127.1 plus or minus 0.05 volts, it means that the error range is trying to tell us the range of the error. This implies that the voltage is between 127.05 and 127.15. So that's the range of the this thing. For us to have an accurate, we don't know the exact value. So we are trying to say, okay, there may be a plus 0.05 or a minus 0.05. So within that range, that's where the actual voltage lies. The actual voltage lies. So sometimes we take we do take that into consideration. Now we're going to say addition, subtraction, multiplication, and division of measurement errors. How we add them together. When you make some calculations and you're having several of these and you need to add them together, there are rules to add them together so that we don't make mistakes and render the what you're trying to measure inaccurate. So now we're going to take this first example. It says an experiment uses a digital voltmeter to measure an electrical potential difference of exactly 15 volts. So now we're trying to measure in this experiment the measured using a digital voltmeter. They're trying to measure the voltage across maybe the circuit, and they got 15 volts. Now they say that the instrument reads from 0.00 to 19.99, knowing fully well that there is going to the maybe the instrument has been calibrated as 20 volts, but now it's reading 19.99 volts. So there's still some missing 0 point something volts there that is still missing to make it complete. So in this particular question, there are two types of errors. If you look at it clearly, the first error is associated with the accuracy of the device, which is plus or minus 1%, and the second error is associated with the design itself, the design of the voltmeter in this question. For us to find the range of possible errors, we have to find the effect of each errors on the solution. Then we add both errors together. Now we're having two types of error here. We're having an error due to accuracy, due to the accuracy of the instrument, and then we're also having an error due to the device itself. So now we have to find these errors and add them together. Now firstly, the solution. This particular lecture notes will be found on our website. You can always visit it to get the soft copy of this. Now we measured some 15 volts. That was what we measured, and now they're telling us that we have an accuracy error with an accuracy of this. So the accuracy of plus or minus 1%. Now that plus or minus 1% will be 1 over 100. That's 1 over 100. So we're going to multiply what we got to calculate the percentage error, the particular error of that accuracy that was associated with accuracy. We have to say 15 volts times 1 over 100, because this 1%. So that's 1 over 100. So 15 volt times 1 over 100. So now I've gotten 0.15 volt. Now 0.15 volt. Now let me point out something here. This is to get the error associated with the accuracy. We can as well say the error is 15 plus or minus 1%. But later on, when we solve more problems in this particular lecture note, you will see why we have to convert the 1% to a particular number, because for us to be able to add two errors together, we need to first convert them. We convert the 1% to an actual number, and then we add the errors together. So in this now, we got 0.15. So the error there will be 0.15 volt. Now, so the range of error associated with the accuracy, it will be 15 plus or minus 0.15 volt. 15 plus or minus 0.15 volt. Now, the error associated with the voltmeter, also in the question, we can see that it's plus or minus 1% also. So we convert this 1%. We convert this 1% to the actual error. So now 1% is equals to 1 over 100, which is 0.01. Because this is an error associated with the voltmeter. It was added to the accuracy error. So now we got 15 volts, which is this 15 plus or minus 0.01, plus or minus 0.01. So after that, we add both errors together. Now there's a way we add these errors together. Now we're having 15 plus or minus 0.15. We're also having 15 plus or minus 0.01. So once we add both errors together, that's 0.15 plus 0.01, we are going to get 15 plus or minus 0.16. 15 plus or minus 0.16. So the total errors that occurred in that particular reading will be 0.16. That's it. So let me come again. Firstly, in this particular question, we can see that there are two types of errors that occur. The error due to the accuracy of the measurement itself, and the error associated with the voltmeter itself. So we had to convert the errors to an actual number that would be easier for us to add together, and then find the total number of error that occurred. So that was what was done here. So the second example, it says calculate the voltage drop across the resistor to the approximate number of significant figure if the resistance is 48.92 ohms and the current is 2.28 amps. Now we are giving the resistance, we are giving the current, and they say the voltage that they're trying to calculate the voltage across the resistor. And now we're giving the resistor and the current. So from this equation, we know that V voltage is equal to the current multiplied by the resistor. So now when you carry this out in the laboratory, and maybe some some way you encounter some certain error, maybe in the measurement of the current and the measurement of the voltage, there are ways that we can add that two together. We're going to be seeing in the later part of this lecture, but let's focus on what we're told to do in this example too. So according to the question, they said that we should calculate the voltage drop across the resistor to the approximate number of significant figure. So now we are dealing with significant figure here. So using the formula V is equals to IR, now we are given our the resistor value to be 48.92 and the current to be 2.28. Now the R that we're given, the resistor value, is 48.92. Now we can see that we have four significant figures there. There's no zero among them, so we're having 4, so that's 48.92. So that's 4 significant figures. Then the current, we're having 3 significant figures. You can clearly see this is 1, 2, 3. So 3 significant figures. Now when you multiply two of them together, they say we should calculate the appropriate number of significant figures. Now we should try to understand that it is the one with the least significant figure that will be the final solution. Least significant figure. Now when you multiply both of them together, we have when you multiply these two together, we have 111.53. So we need to make sure that it is three significant figure, because three significant figure is the least significant figure in the question. You can see from my notes, I said there that, but in the question we have to calculate the approximate number of significant figure. In any of these case, you should calculate to the least value of the question, the least value of the question, the least significant figure in the question. So now in this case, we have one with four significant figure, and we also have one with three significant figure. So the least of this should be three significant figure. So our final answer should be in three significant figure. And since we know from this our answer here, 5 is we approximate it to 1, and then we add it to this, we have 112 volts. So you know how to convert to the nearest significant figure. So if anything is above 5 to 9, or to 9 point anything to 9, then you approximate it to the nearest one. If it's 0 to 4, then it will be you take it backward. If it's 5 to 9, you take it forward. Then if it's 0 to 4, you take it backward. So let's say this particular value was 111.4. we'll take it backward, so it will be 111. But because it's 111.5, which 5 to 9, 5 and above, you approximate it forward, so that's 112 volts. Now we are now going to go into the addition of the errors that I was talking about in Excel, and that's the main idea of this error measurement. Now we are told to add 12.25 plus or minus 0.05 to 6.72 plus or minus 0.01. And how do we go about this? Firstly, the solution is we are first going to add the normal values, because they say we should add together. And in the case of addition, when we have to add two particular numbers with their errors, we add their errors two together. So firstly, let's add the main values. The main values are 12.25 plus 6.72. So when you add that one together, it will give you 18.97. Now you add the errors together. So once you add the errors together, that's 0.05 plus 0.01. Once you add them, that's 0.06. So then you now say 18.97 plus or minus 0.06. I hope that's well explained. And if you go through the next lecture notes, again, we're available on my website, www.techglobal.com. You go there for the lecture notes, you can go through it again, you'll be able to understand what is written in there. And also we have another example. We're adding two numbers together. Also add 18.20 plus or minus 0.02 to 4.76 plus or minus 0.02. Now, as I've said, for the addition rule, you add the main values together and then you add the errors together. So the main values is 18.20 plus 4.76. You add those two together, and then that's 22.96. And after you're done adding that one, you add 0.02 to 0.02, which is 0.04. So we have 22.96 plus or minus 0.04. Now let's go to subtraction. How do we treat the case of subtraction? Subtraction is different from the addition aspect. Now, firstly, for you to be able to treat the case for subtraction, you subtract the main values, like the main calculations. The main calculation, you subtract them from each other, and then you add the errors together. You add the errors together, but you subtract the main calculation from each other. How is that done? Let's go to this example 5. Subtract 12.25 plus or minus 0.05. It's supposed to be, it's not 2, it's supposed to be subtract, okay, there's some sort of mistake right here. subtract this from this. Sorry for that mistake. It says subtract 4.76 plus or minus 0.01 from 12.25 plus or minus 0.05. Now, the first step, subtract the main calculation from each other, which is 12.25 minus 4.76. 12.25 minus 4.76. So we're going to get 7.49. That's the main calculation. Then we add the errors together. That will be 0.01 plus 0.05. So our solution will be 7.49 plus or minus 0.06. Now here's another example. Sorry for the statement, the way the example is stated. I'm correcting it. It should be subtract this from this. Copy. From this. So you should be subtract that from that. So now subtract 4.76 plus or minus 0.02 from 18.20 plus or minus 0.02. Now, as we have said, subtract the main values from each other and add the errors. That is the rule for subtraction. So let's get to the solution. Subtract the main value, which is 18.20 minus 4.76, which is 13.44, and then add the errors together. 0.02 plus 0.02, which is equals to 0.04. So then you combine both of them together. 13.44 plus or minus 0.04 will be the solution. Now we're having the percentages. So this should be similar to the first question that we kind of answered. Now, when you are told to add 50 plus or minus 10% to 20 plus or minus 5%, how do we go about that? Firstly, try to convert it to a number, like a number. Let's take it away from percentage and try to convert it to a number. So how do we do that? We say 10% of 50 will be 5. Which 10%, that's 10 over 100 times 50 will be 5. So then that's the number. Now it will now be written in the form of 50 plus or minus 5. You understand me? So firstly, as I've said, convert the percentage to a number. So in this case, it is 10% of 50, which is 5. Then I added 50 plus or minus 5. Now, for the second part, we are going to say 5 as 5%. 5% of 20, that's 5 over 100 multiplied by 20, which is equals to 1. So we have 20 plus or minus 1. Then we'll follow the normal addition rule. Addition rule that I've stated. Add the errors together and add the main values together. So 50 plus or minus 5 plus 20 plus or minus 1. When we add them together, we add the main values together, that's 70. We add the errors together, that's plus 6. Then we now convert back the error into percentage because we are given a percentage in the initial stage. So we say we're going to convert 70 plus or minus 6. We'll convert it back to percentage, which will be 6 over 70 times 100% will be 8.6. 8.6. So the answer will be 70 plus or minus 8.6. So for the percentage rule, convert the percentage to a normal number, then add both of them together, then convert back to percentage. Now we are going to have this example 8. We are having subtract. Okay, the same error is here. Let me correct this. Yeah, subtract this from this, 20 plus or minus 5% from 50 plus or minus 10%. The same rules applies. Firstly, convert the percentages to number, which is 10 over 100 times 50, which is equals to 5. 10 over 100 times 50, which is equals to 5. Then, once it will now be written 50 plus or minus 5. Then for the 20 also convert, which is 5 over 100 times 20, which is 1, to be written 20 plus or minus 1. Then we subtract 20 plus or minus 1 from 50 plus or minus 5. Now we have to follow the subtraction rule. Don't forget the subtraction rule. Now, which says that we should subtract the main values from each other and add the errors. So subtract the main values, so that what the main values are 50 minus 20, which is 30. Then add the errors, which is 5 plus 6. 5 plus 1 is equals to 6. Now, then after we have done that, we are going to convert back to percentage. Convert back to percentage, which should be 6 over 30. 6 over 30 times 100%, which is 20%. So the answer will be 30 plus or minus 20 percent. 30 plus or minus 20%. Now we're going to go to example 9, which is multiplication. So in the multiplication rule, firstly, you multiply 12.1 plus or minus 0.2 with this. We are told to multiply 12.1 plus or minus 0.2 with 6.0 plus or minus 0.3. So the rule is very clear. Firstly, the rules for the multiplication says that multiply the worst case value using positive limit. The worst case value using positive limit. Multiply the original numbers. The result is the product of the original number. The product of the original numbers, and the range of error is the difference of the first two steps, the original number and the worst case value. So let's follow that. In this case, say multiply the worst case value using positive limit. So what are the worst case value? The worst case value using positive limit. So worst case value, that's 12.1 plus 0.2, because they say we should use positive limit. That's 12.1 plus 0.2, that's 12.3. Now 6.00 plus, using the same positive limit, 0.3, that will be 6.3. Then we'll multiply them. Multiply the worst case values. The worst case values are the errors, using the positive limit, that we should use the positive one, not the negative. So we added 12.1 to 0.2, 6.0 to with 0.3. When we multiply that, then we multiply together, that will be 77.49. Then we're going to multiply the original numbers without the errors. So 12.1 multiplied by 6.0, we got 72.60. Then the result is equal to the product of the product of the original number. The main result is equal to the product of the original number, which is 12.1 multiplied by 6.0, which is 72.6. That will be 72.6. And then the range of errors is the difference of the first two steps. So which is 7.77, which difference of the first two steps. That's the first step is 77.49 minus 72.60. 77.49 minus 72.60, which will be 4.89. So this will be the error. So it will be 72, which is the original number, 72 plus or minus 4.89. Now let's recap on this example 9. Firstly, multiply the worst case value using the positive limit. So multiply the worst case value using the positive limit, which is 12.1 plus 0.2, multiply by 6.00 plus 0.3. Multiply both of them together, which was done here. The addition, 12.3 multiplied by 6.3, that's 77.49. Then multiply the original number, 12.1 multiplied by 6.0, so you get 72.60. This will be your mean value. 72.60 will be your mean value. Then the range of error is the difference between 77.49 and 72.60. That's 77.49 minus 72.60. That will be a range of error. So it will be 72.60 plus or minus 4.89. Now let's go to the division. Let's go to the division aspect, and that will be final for lecture 1. So the division aspect, what you have to do, it has rules that you need to follow. So in this one, they say divide this with this. Divide 12.1 plus or minus 0.2 with 6.0 plus or minus 0.3. Rules to follow. They say divide the first number plus its positive limit by the second number plus its negative limit. So now you say divide the first number plus its positive limit by the second number plus its positive limit. So now it said that divide 12.1 plus its positive limit, which is 0.2, and then with 6.0 plus its negative limit, that's plus minus 0.3. Plus times minus will be minus, that will be minus 0.3. So that was done, what was done here. So 12.1 plus 0.2, following the rules, it will be 12.3 divided by, now 6.1 plus minus 0.3 plus, because they say in the rule, they say by the second number plus its negative limit. So you can simply say 6.0 minus 0.3. 6.0 minus 0.3, we got 5.7. So we're going to divide the 12.3 divided by 5.7. We're going to get 2.15. After I've gotten that, we're going to divide the original numbers the way they are. Divide the original numbers according to the rule, second rule. Divide the original numbers, which is 12.1 divided by 6.0. Once you do that, you get 2.01. Then the result, the main result, will be the division of the original number, which we did in 2, which will be 2.01. And then the range of errors will be the difference of the first two steps, which will be 2.15 minus minus the original 2.01. So it's going to give us 0.14. So the answer will be 2.01 plus or minus 0.14. 2.01 plus or minus 0.14. Quick recap on this particular question. Divide this with this. Firstly, divide the first number plus positive limit by the second number plus its negative limit. First number plus its positive limit. The positive limit is plus 0.2, that's 12.3 here. That's 12.3 here. Then divided by with the second number plus its negative limit. So plus times minus will be minus. So it will be 6.00 minus 0.3, which was what was done here. It's 5.7. The second number plus its negative limit. Plus times minus will be minus. So that's 6 minus 0, that's 5.7. So divide 12.3 divided by 5.7, we're going to get 2.15. Then we should divide the original number, which we are going to get 2.01. The main result will be the original number, which is 2.01. The range of errors will be the difference between 2.15 minus 2.01, which is 0.14. So the answer will be the main result, which is 2.01 plus or minus 0.14. I hope you have learned something. I'm going to be doing some little more videos in which we're going to solve more problems, and some problems, some tests for you will be on my website. You can visit my website. The link is on my YouTube page. And please don't forget to subscribe to my channel, give this video a thumbs up, and see you in the next lecture.